Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ali Syahirah binti Rosli 117084. So, me and my friends are choosing the nanotextile as the one of the applications in the nanotechnology. In our video, we have covered the introduction part, the properties of the nanotextile, and then the application of the nanotextiles, and also the conclusion. Okay, firstly, for the introduction, the nanotechnology has recently brought immense improvement in the textile industry. The nanotechnology is known as objects or instruments in which the parts are smaller than 100 nanometer in at least one dimensions, or 1 millionth of a meter, 10 to the power negative 9 meter, about 18,000 times smaller than human hair. Different methods have been used for production of nano-engineered textile. For examples, the synthesized nanoparticles are incorporated into the fibers or textile, and then it also applied as a coating on the surface of finished products. And then there are also the nanoparticles that are added to the nanoscale fibers or coating. Thus, the applications of the nanotextiles can lead to the development of the nanofibers, nanocomposites, nanopolymers, and also nanofinish. And nano is used in the textile to develop desired textile characteristics, such as the tensile strength, unique surface structure, soft hand, durability, water repellency, fire retardancy, and also the antimicrobial properties.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Najah binti Muhammad Sri, matrix number 117024. I will explain on the properties of nanotextile fiber. There are few properties being imparted on the textile which include water and oil repellent property, antibacterial and antimicrobial property, wrinkle resistance, UV protection, and anti-static. Information on nanotechnology and textile mutually assist to progress and advance conception of self-cleaning textile, in which the textile possess an ability to be cleaned with no laundry treatment. There exists two diverse methods prevalently utilized for the advancement of self-cleaning textile, which are photocatalytic activity and dilatus effect. In the case of the photocatalytic activity method, zinc oxide or titanium dioxide nanoparticle-based coating or finish formulations are utilized to develop self-cleaning textile. The lattice effect is produced by the surface modification of the textile fabric by nanocoating or nanofinishing, usually by utilizing surface-modified carbon nanotube, zinc oxide nanorod, nanozirconia, or nanosilica. Let's take a look at the video about a product that demonstrates the lattice effect. Textile fabrics, particularly ones made up of cellulose fibers like viscose, linen, and cotton, have a greater tendency to be harmed by microorganisms. For example, protozoa, algae, fungi, viruses, and bacteria in the course of their surface life. The cotton fibers also illustrated fine antibacterial efficacy after numerous washing, making it appropriate for medical usage with an ease. For imparting antibacterial properties, nanosized silver, titanium dioxide, zinc oxide, triclosan, and chitosan are used. Nanomaterials with a higher surface area to volume ratio contribute a superior antimicrobial characteristic relative to traditional antimicrobial agents. Economical and eco-friendly antibacterial properties of cotton fibers loaded with silver nanoparticles prepared from natural Chinese holly plant extract were studied by previous researchers. Let's take a look at a video that uses nanosized silver in antimicrobial fabric.
An antiviral textile technology combining HiQ's advanced silver and vesicle components that can be applied to any fabric to make them extra resistant to viruses and bacteria. Silver emits silver ions to kill any bacteria on the fabric surface. Just like a magnet, the positively charged silver attracts the negatively charged virus and tries to attack it with silver ions. However, envelope virus membrane is like a shield protecting the virus from silver ions. The vesicle technology, which is a cosmetic-grade liposome, helps to deplete the viral membrane quickly so that the silver ions can attack the core of the virus and destroy the virus rapidly. With HiQ ViroBlock, fabrics are no longer the hosting surface for viruses and breeding ground for bacteria.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Nabila binti Maidin and I will be continuing on the properties of the nanomaterial textiles. UV protective textile. UV stands for ultraviolet radiation. Because of the depletion of ozone layer in the atmosphere, UV radiation is entering the surface of the Earth. Thus, it can bring harmful effects for both the body and the clothes. Latest study has shown that the certain metal oxide nanomaterials like magnetic nanoparticles, titanium dioxide particles, zinc oxide particles, and nanoceria can successfully block the UV radiation. It can guarantee the materials used to be as organic ultraviolet swiper. It brings properties like harmlessness to the body, chemical stability under UV radiation, and able to withstand higher temperature exposure. Latest research also shown that zinc oxide nanoparticles were in situ prepared on the modified cotton fabric for developing multifunctional fabrics. It demonstrates superior ultraviolet protection and substantial antibacterial effectiveness up to 100 abrasion circle and 20 version circle. Thus, it can be used as innovative protective textile. Can conclude that these nanotextiles are smart, sustainable, and durable. Anti-static textile. Anti-static refers to the material that inhibits the static electricity. The study has shown that titanium dioxide nanoparticle and other nanoparticles can be used to provide anti-static ability in this fiber. Due to the nanomaterials are conductive in the nature, it can dissipate static on the surface of the material. Wrinkle-resistant textile. Wrinkled clothes are such a mess, particularly on the cotton fabrics that are extremely vulnerable in developing creases at the time of usage. The silicon dioxide nanoparticle and titanium dioxide have the ability to restrain certain restriction to the crease as they by hug at all. It can be used by utilizing 1 to 3 butane tetracarboxylic acid, nanopolyurethane for clear shrinking process, and aluminium oxide nanoparticle for catalyst in the padding procedure that can advance the flame retardant, wrinkle resistant, and durable finishing of a liner. Another study shows that flat fibers applied with the aluminium oxide nanoparticle can improve the flame retardant and wrinkle resistant.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nushafira binti Mazlan. Mention number 1171455. Me and Izzati will explain about the application of smart nanotextiles. There are 6 applications which are sports, medical or healthcare, military or security, fashion, technology and home.
The first application is sports. Sports sector in nanotextiles to improve athletic performance, personal comfort and protection. For example, a breathable waterproof fabric such as Cortex and moisture management textile like Coolmax, which is used to moisture away from skin, and it is possible to maintain constant body temperature using phase change technology used in Outlast adaptive. This figure is an example of smart nanotextile devices which used in sports to teach athletes the correct way to perform movement skills by providing real-time feedback about limb orientation. It shows carbon-loaded electrosensorized garment, the piezo-resistive sensor fabricated on a lycra or cotton text. Next application is healthcare, which is a wearable device allows physiological signal to be continuously monitored. Two EU-funded projects by Wearable Healthcare Systems Health and My Heart involve a wearable textile interface integrating sensors, electrodes and connectrons, realized conductive and piezoelectric ions to tackle cardiovascular disease, which are the leading cause deaths in Western world. For example, like in the picture that I have provided, which is on body sensors and electronics for monitoring vital body signs, a garment textile ECG electrode developed by My Heart to prevent heart. The third application is military or security. There are two examples for the application of smart nanotextile in military. First one is Smart Shirt Sensor Tech, which was initially developed by Giorgetti and for military application. The t-shirt function is like computer by means of optical and conductive fibers integrated in a garment. The optical fibers used to detect bullet wounds, pinpointing their exact location and various sensors to monitor body during combat conditions. For example, the ISM used nanotechnology to improve their soldier survival. It is used to secure a lighter, faster, more agile fort with a heightened awareness of its environment. Second example is a live shirt Vivometrics, which is a sleeveless undergarment as a multi-channel cardiopulmonary digital recorder which can monitor more than 30 vital signs. The live shirt system is an extensible data acquisition and processing platform which consists of a garment, data recorder and PC-based analysis.
Assalamualaikum, my name is Nur Izzati binti Muhammad Azizi, 117035. So, I will continue with the other application.
Fashion. Textronics develop fabric that can warm, illuminate, conduct, and sense. One of their recent developments is the new Matrix heart rate monitoring sports bra, which incorporates conductive knitted sensor that link wirelessly to a heart rate monitoring watch. Technology. Electron has developed fabric touch pads integrated into jacket for more accessible control of MP3 players. The initial application was for snowboarding jacket to provide ease of access to the control buttons. Electron has also developed a fabric keyboard for personal digital assistant (PDA) that can be rolled out, easily stored and transport. Home. To add antibacterial properties, nano-sized silver, titanium dioxide, and zinc oxide are used. Metallic ions and metallic compound display a certain degree of sterilizing behavior. It is considered that part of the oxygen in the air or water is turned into active oxygen by means of catalysis with the metallic ion, thereby dissolving the organic substance to create this sterilizing effect. By using nano-sized particles, the number of particles per unit area is increased, and thus antibacterial effect can be maximized. Antimicrobial coatings are widely applied to socks in order to prohibit the growth of bacteria, but their use also extends from wound dressing to home furnishing, carpet and clothing.
So finally, in the conclusion, there are many properties and the applications of the nanotechnology in the textile. There are two focus in the future developments of the nanotechnologies in the textile, which are, firstly, the upgrading existing functions and performance of textile materials. And also, secondly, the advancement of the technology, which is the new function which textiles to be developed.
That's all from us. Thank you.